Humanity has spent thousands of years dreaming of mechanical beings. In Greek mythology, the god Hephaestus supposedly forged golden servants and a bronze giant named Talos to patrol the island of Crete. We have always been fascinated by the idea of a smart helper that could act on its own. For centuries, that remained a fantasy. But in the last few years, tools that write, code, and generate images have arrived with overwhelming speed. Suddenly, the ancient dream of a thinking machine feels like a daily reality. This rapid arrival has outpaced our collective understanding. It has created a vacuum where AI is viewed through a lens of polarized panic, either as an omnipotent solution to every human problem or as a malicious overlord designed to replace us. Operating under these science fiction myths leads to catastrophic business decisions and ethical failures. When we misunderstand the technology, we misjudge its risks and its potential. To survive this transition, we need to move past the stories we've told ourselves. We must look at the mechanical reality and the mathematical rules that actually drive these systems. The first step is to recognize that AI does not possess human-like consciousness. It is applied mathematics with a long history, rooted in the 19th century work of Charles Babbage and his mechanical calculators. In the early days, researchers tried to build symbolic AI by writing a giant human-programmed rulebook. It functioned as a massive list of if-then statements. If you wanted the computer to know what a cat was, you had to manually code every specific rule about whiskers, fur, and ears. This approach eventually hit a wall called the combinatorial explosion. The real world is too messy for simple rules. To solve even basic problems, the number of if-then branches would multiply into the billions, causing the code to become unmanageable and brittle. The breakthrough happened when scientists stopped trying to hard-code every rule. Instead, they began feeding machines massive datasets, thousands of examples of a specific object, and allowed the algorithm to identify the underlying patterns itself. This transition to machine learning provided a significant leap in data processing capability. It allowed computers to act on complex information at scale without the need for a digital soul or human-like reasoning. Modern machine learning functions through a consistent three-step loop. Step 1 is data collection. The system ingests staggering volumes of raw information, text, images, or numbers, to build a foundation for its calculations. Step 2 is training. Here, the algorithm analyzes the data to find structural patterns, mapping out the statistical likelihood of how one piece of information relates to another. Finally, in the testing and prediction phase, the model applies what it learned to new inputs. It calculates the most probable result based on the patterns it found during training. We guide this learning in 3 ways. Supervised learning uses labeled data, unsupervised learning finds hidden relationships in raw data, and reinforcement learning uses a trial-and-error system of rewards and penalties. IBM's Deep Blue supercomputer illustrated the power of crunching data in 1997. It defeated the human world chess champion by rapidly analyzing millions of historical moves and calculating probabilities, rather than employing human intuition. This loop confirms that AI is a tool for probability. It doesn't think in the biological sense. It predicts outcomes based on the historical data it was fed. Because this system is purely mathematical, it has severe limitations. There is a persistent myth that more data automatically results in a better AI, but quantity cannot replace quality. If the training data contains flaws or historical prejudices, the algorithm will amplify those biases in its output. A system trained on skewed hiring records will inherently favor the same patterns, regardless of a candidate's actual merit. There are also hidden burdens to consider. Implementing AI requires massive financial investment and complex integration. Keeping that data clean and relevant demands constant, expensive human maintenance to prevent the system from becoming obsolete. Over-reliance on these tools is an operational risk. AI inherently lacks the common sense, emotional context, and true creativity required to navigate sensitive or unpredictable situations. Since AI is strictly bound by its data, deploying it without human oversight is a gamble. It is a powerful tool, but it requires a person to own the final outcome. These limitations directly address the fear of human obsolescence. The idea that AI will cause total job loss ignores the reality of how the workforce is actually changing. We are seeing a divide into two roles. First, there is the AI builder. These are the technical experts and engineers who design the core algorithms and manage the data infrastructure. Then there is the AI operator. These are professionals in every industry, from marketing to finance, who use existing tools to automate their workflows and build specialized agents to increase their productivity. The reality is that the algorithm itself will not replace a human professional. However, a person acting as an efficient AI operator is a formidable competitor to anyone still working manually. Job security in this landscape requires treating AI as a manageable productivity tool. You must learn to direct the machine rather than trying to compete against its processing speed. Because these systems are flawed, they require a mandatory human in the loop. We need people to verify evidence, consider context, and make the final call in high-stakes decisions. This oversight can be managed through the SAFE framework, implementing safeguards, maintaining human accountability, ensuring fairness across all data groups, and investing in continuous education. These aren't technical coding skills. They are inherently human traits, logic, creativity, and ethical judgment that remain the most valuable assets in an automated world. This has always been the case. The foundation of this technology was laid by dreamers and logicians like Alan Turing, who used human curiosity to define what a machine could one day achieve. By stripping away the science fiction and understanding the underlying mechanics, AI reveals its true nature as humanity's most capable smart helper. It is a tool that works for us, provided we remain the ones in control.